Hello, this is John from TC Math Academy, and what I have for you here seems like a pretty basic algebra equation we want to solve for m. So we have 3 minus the square root of 2m plus 2 is equal to 8. Now, at first glance, a lot of you may look at this equation and say, oh, I can do this, not a problem. But I'm going to tell you right now, a good majority of you, I don't know if it's exactly 99%, but most of you out there are going to get a certain aspect of this problem confused, or you're not quite really know what's going on, and it's not your fault. I don't think most algebra textbooks do a really good job with this. At least the ones I've seen over the years, they don't really kind of emphasize a certain point because there's so many students that still have questions on a specific, very, very critical aspect to solve these type of problems. Now, I don't really want to discuss this much more at this point because I want to give you a full opportunity to kind of see where you're at. So if you can solve this equation, put your answer into the comment section. I'm going to show you the correct answer in just 1 second, and then I'm going to go through something that is very, very critical for all of you out there that are studying any sort of algebra. This is really, really important stuff. Also, if you need math help with the course you're taking, test prep, or homeschooling, make sure to check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so here is the equation, and what type of equation this is. This is what we call a radical equation. The objective here is to solve for m. So let's go and take a look at the answer right now. So here I have two answers, two possible answers. One of these is the correct answer, the other is not. Okay, so which one did you get? Now, maybe you didn't get either one of these answers, and if that's the case, well, I'm going to explain this problem, how to solve this problem fully in just one moment. But how many of you selected this problem or this solution right here? Did you get this as your answer? Well, if you did, well, that is fantastic because unfortunately, I got to give you a little sad face. And I'm happy that, in fact, you're saying that this is the answer. Okay, again, most students that feel like they know how to do this problem would say, yes, this is the correct answer, but it's actually not. Okay, this is the correct answer. And this m is equal to, this is not 0, this is the empty set or null. Basically, there is no solution to this problem. So if you got this answer, let's go ahead and celebrate with a big, huge happy face, and A++ and 111%. Now we'll make it 110% and multiple stars so you can tell your friends and family that you know exactly what's going on when you're solving radical equations. But really the thing that's going on here, the kind of main point to this video is to talk about something called extraneous roots and how to check solutions in a radical equation, especially when you're taking square roots. This is a very, very confused area in algebra. And again, I don't believe it's primarily the student's fault. I have a ton of math books. I mean, I've kind of collect them. Some of you might be saying, "Well, you got to get a life, Mr. YouTube Math Man. Do something other than math." Well, listen, I've been teaching math for decades, but I have a huge, huge library of old books from like the 1950s, 60s, 70s, 80s of algebra, trigonometry. You kind of name it because it's interesting to see how through the decades math was taught. So, I study a lot of these books and try to get good ideas. So when I teach math, I can kind of emphasize certain points. But some of the more modern books just don't seem to make this one very critical point clear enough. Anyways, I'm going to explain this fully right now. So let's get into the problem. So here is the problem, right? So we have 3 minus square root of 2m plus 2 is equal to 8. So again, this is a radical equation. Now, in general, I'm kind of just erase this real quick. How do we want to solve a square root or radical equation? Okay, specifically, this is a square root situation. What you want to do is we want to get the square root to one side of the equation and some number on this side of the equation. So we got to clean up the equation such that we have the radical or the square root on one side, the left-hand side, and just one number on this side. So when we get to that point, we can get rid of the square root by squaring both sides, okay? And then we're going to be left with whatever is inside that square root equal to that number squared, and then we can just solve that remaining equation. And it's very, very critical that we check our answers to this equation for extraneous solutions. Okay, so that's one aspect to this problem that we're going to be talking about, but there's even a more critical aspect that confuses students. So, but in general, this is kind of the approach that we need to take. So let's get into that right now. All right, so the first thing I need to do is move this 3 to the side. So I'm going to subtract 3 from both sides of the equation. So that's going to give me negative square root of 2m plus 2 is equal to 5. Okay, so again, I'm just subtracting 3 from both sides of the equation. Now at this point, what do I have? Well, I have my square root on one side, my radical, and I have one number. So I'm in a position now to go ahead and square both sides. So when I square both sides, I also have to square this negative in front of this square root. So it would look like this, right? So a negative squared, if you multiply this by itself, you're going to have a negative times a negative, which of course is a positive. So what's going to end up happening is this whole radical is going to drop away, right? So we're going to go from this to this. In other words, when we square a square root, you're just going to get what's inside the square root, right? And of course, that's 2m plus 2. And then on the right-hand side, 5 squared is 25. Now, if you were doing this, I mean, this is still good work. Even if you got the wrong answer, of course, I'll show this here in a second, but if you were like doing this, this is exactly what you need to do. So you weren't all, quite wrong. But again, we'll talk in just in 1 second on how to check these equations, all right, the confusing part. So let's just continue to work this problem. So we have 2m plus 2 is equal to 25. So now I need to subtract 2 from both sides of the equation. So that's going to give me 2m. Whoops, I didn't want that. All right, get my highlighter. So 2m is equal to 23. And then to solve for m, I simply have to divide both sides of the equation by 2. So I get m is equal to 23 over 2. Now, if you were able to do this, that's very good. Matter of fact, I will even give you a happy face. No A plus, no 100%, but that's very, very good. However, what you need to realize is the following, okay? If you thought, for example, you were done at this stage, you're like, okay, I'm done, here's my answer, I'm good to go. Well, no, you are not, because anytime in algebra where you square or multiply both sides of the equation by a variable or a variable expression, and that's what we're doing here. We're actually multiplying both sides of the equation here by 2m plus 2. Okay, so at this point, we can introduce what we call extraneous solutions, extra solutions. So by virtue of doing this step, just means that, okay, the resulting equation, which is this right here, we could pick up extra solutions that are not actual solutions in the original equation. So therefore, okay, you must always check these answers. These are just potential answers, or they're good candidates as solutions to the original question or to the original problem. The only way to know is to check these answers. Okay, so if you were like, yes, I knew that, Mr. YouTube Math Man, well, that is outstanding. And I'm not even at the most confusing part of this problem. All right, so let's get into this second phase now, right? So we solved for this equation. We've got 23 over 2. We believe that this is a good solution. The only way to know whether in fact it is or not is to plug it back into the equation and check. So we're going to replace this m right here with 23 over 2. You can see that work right here. And then we're going to simplify and see what comes up. All right, so let's go ahead and do this math. So we have 3 minus the square root of 2 times 23 over 2. So you can see the 2's are going to cross cancel right there. So this is just going to be 23 plus 2 underneath this square root. And we continue on, and we're going to get 3 minus the square root of 23 plus 2, which of course is 25 is equal to 8. All right, so at this stage, this is where the fun begins. This is where a lot of students are like, I'm not quite sure what to do next. Well, that's a happy expression. Maybe something like this. All right, what's the next step? Okay, this is the part here we are going to talk about right now. Okay, so here is what all of you have been waiting for. You're like, hey, just get to the punchline. Hurry up. Tell me what what confuses students. This is the area that really confuses a lot of people. So we have 3 minus the square root of 25. No problem, right? So you're like, yeah, I know what the square root of 25 is. Now, some of you are going to say, well, it's 5. Or some of you are going to say, well, it's 5 and negative 5, right? So which one is it? What's the answer to square root of 25, right? Is it 5, or is it the square root of 25 positive and negative 5? Okay, well, let's look at this real quick here. So 5 times 5, remember the square root is, the answer is going to be a number such that you multiply by itself, you're going to get back to this number. So 5 times 5 is 25. That's good. And negative 5 times negative 5 is also a positive 25. So technically, the square root of 25 should be both positive and negative 5, right? So this is what most students, kind of think. They're like, oh yeah, positive 5 or negative 5. Well, maybe it's both, right? Well, this has huge implications on the final answer here, okay? So I'm not yet at the point of explaining this. Let's just suppose that you think that is, you're convinced that the square root of 25 for this, for the purposes of checking this problem, okay, is both 5 and negative 5. So if it's negative 5, we can plug that in right there. I'll get to this positive 5 in a second. And we can go, well, 3 minus a minus 5, right? Because here we're down to checking this equation, 3 minus the square root of 25. Again, we're going to call that square root of 25 negative 5. So 3 minus the square root of negative 5. Is that equal to 8? Well, 3 minus a minus 5 is 3 plus 5. So that's equal to 8. So this looks good. Okay, you're like, yay, I did this. I'm going to get an A plus because my negative 5 right here worked. Okay, unfortunately, this is wrong. And you're like, what are you talking about? Wrong. You might be like this. You might be like really upset. You're like, you're wrong, Mr. YouTube Math Man. I'm right. Well, listen, again, this is a very confused and somewhat kind of contentious debate. All right. Well, now I'm going to go ahead and clarify what to do right now. Okay, like what's going on. All right. So this is a point again that I think is taught. It's definitely taught in, well, I don't want to say all textbooks. I've seen this kind of not really brought up in a lot of algebra textbooks. And when it's brought up, it's not really emphasized as much as I personally would like it. Okay, now I could be wrong, and some of those textbook publishers could be, right. But, again, I've been doing this for decades, and, it's just one of these things I just don't think is emphasized enough. All right, so what is the big point here? If I give you a problem like this, the square root of 25, let's suppose you're in like 7th grade, 8th grade, or whatever the case is, and I say, don't use your calculator, just tell me what the square root of 25 is, all right? Most students are going to give me the answer positive 5. This is correct, all right? This is right. Now, some of you are saying, well, shouldn't it be positive and negative 5? No, okay? The answer is no. We should not have positive and negative 5. Now, why is that? Well, it's because when we take the square root of a number, just in and of itself, like a situation like this, what we're looking for is something called the principal square root. Principal square root, which is the positive version of that answer. Just kind of think of it that way. So the square root of 25 is a positive 5. There's only one answer to the square root of 25. That's positive 5. Okay. So this, again, goes to this concept called the principal square root. So some of you might be saying, well, what about this positive negative business that I've been doing in algebra? Well, let's talk about that right now. So let's suppose I give you an equation like this to solve. X squared is equal to 25. So what type of equation is this? All right, x squared. X squared is equal to 25. Hopefully you recognize this as a quadratic equation. This is a quadratic equation. Okay, I'm trying to solve this quadratic equation. And there's this real fancy thing called the fundamental theorem of algebra, because this is a 2 right there, indicates that this equation, this quadratic equation, will have two solutions. It must have two answers. So when we're solving a quadratic equation, to get to the solution, x squared is equal to 25, what we're going to do is take the square root of both sides to get to x, right? So the square root of x squared is going to be x. And in this case, when we're looking to solve a quadratic equation, or we're looking for roots, like in a polynomial equation, under these circumstances, when I take the square root of 25, I'm going to have the positive and negative, okay, because both of these are, in fact, solutions to this quadratic equation. In other words, one solution is a positive 5, and the other root, or 0, as another kind of term for this, is negative 5. So we have our two solutions right here, positive and negative 5. So yes, indeed, when you take the square root of 25 in a situation like this, you're going for those roots, positive and negative. But just in general, like a run-of-the-mill basic math question, the square root of 25, you're only going to be using the principal square root. So again, this is a quadratic equation, x squared is equal to 25. You're going to have the positive and negative, but let's think about our original equation, okay? Our original equation is not, it's not an x squared situation, it's a square root situation. It's a radical or square root equation. In other words, this is not a quadratic equation. So there is no two solutions, okay? So it's just one. So when you're checking these extraneous roots, when you go in and you plug in these values and you get to the square root part, you only take the principal square root. So the square root of 25 is going to be 5, all right? That's the value that we're going to get. So now we can go ahead and check what happens there. So we're going to end up with 3 minus a positive 5. And is that equal to 8? Well, here you can see 3 minus 5 is going to be negative 2. That is not equal to 8. So this is a false statement, meaning there is no solution. And this is just a fancy term. This little, it looks like a 0. It's not 0. It's something called the empty set or null set. There's a couple of, basically means no solution. Okay, so if you see this, it's not 0. It's not m is equal to 0. It's the empty set. Okay, so I know that was a lengthy explanation, but it is necessary because I'm telling you right now, this is so confused, and for good reason. Okay, I don't think it's, again, really made very clear, at least in the textbooks that I've seen. I've seen a ton of things out there. So when I have an opportunity to, highlight something like this, it will really help you out when you're solving radical equations. Anytime you have a scenario where you have you have extraneous solutions, or you can have where you have to check for extraneous solutions, you need to understand the difference between taking the square root in a quadratic situation or just the principal square root. Okay, so if you need help with anything at this level and beyond, I would direct you towards my Algebra 1 or Algebra 2 course. I also have a ton of additional videos on my YouTube channel, but hopefully this video helped you out. If that is the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.